Hi, this is Open Up Resources, Algebra 1, Unit 1, Lesson 7. What comes next? What comes later? So to start off with, let's just review what makes a sequence an arithmetic sequence. We'll provide an example. Well, an arithmetic sequence has to have a common difference between its terms. So for example, I don't know, let's just start with a 2 and we'll count by threes. 8, 11, 14, dot, 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 dot. Your common difference equals 3. Right? Plus 3. All right, so what makes a geometric sequence? All right, a geometric sequence has to have a common ratio between its terms. So for example, let's start with 3. We'll do a times 2. So 24, 48. Let's see, do I do one more? 48. 48 is 96. 96, dot, dot, dot. So the common ratio is equals a times 2. Right, so addition and subtraction, multiplication, or could say division, but we put it in multiplication forms. All right, so this is going to be our practice lesson as to see if you can identify geometric, arithmetic, or neither. I'm going to practice writing your recursive and explicit equations for both kind of sequences. And these will come from a table. Excuse me. All right, so for each of the following, we're going to identify if it's arithmetic, geometric, or neither. If it's neither, then we're done. That's all we can do. But if it is arithmetic or geometric, we're going to describe how to find the next term in the sequence. We're going to write the recursive equation for the function, and we're going to use that to write the explicit equation. So, and then we're going to write the explicit equation. So let's look at our first table. 1, 2, 3, 4, 5 to 8 to 11. So if it's going to be arithmetic or geometric, we ought to have a commonality between all of these. So 5 to 8 is either a plus 3 or a times 1 point something. So let's try the plus 3 first. 5 plus 3 is 8. 8 plus 3 is 11. 11 plus 3 is 14. So we have a plus 3. Oh, here's our example. So it's arithmetic. To find the next term, we're going to add 3 to the previous. Here's our recursive. They're actually writing it out this way instead of with the brackets on here since it's a line. To find the nth term, we're going to start with 5 and add 3 in times. And that's how we write it as an explicit equation. So these guys are just kind of the word form of this one and the word form of this one. Okay, so it's which is it? Describe the recursive, describe the explicit. Okay, so let's try our first one. Here we have 3 to 15 to 27 to 39. Well, it's either a plus 12 or 3 times 5 equals 15. So which one works here? Well, 15 times 5 is not 27, but 15 plus 12 is. So I'm going to go ahead and erase the times 5. That one is not going to work on here. So it's a plus 12. So we've got an arithmetic. How do we find the next term? We are going to add 12 to the previous term. That makes our recursive equation be f of first term is 3, and then our next term will be our previous term minus 1, and then we're going to have the plus 12 in here. Okay, so to find the nth term, we are going to start with 3. That's our first number here, right? Then add 12. Now if I start with 3, I only need to add 1 to get the second term, 2 to get the third term. So that's an n minus 1 times, right? Starting with the first one, so I don't need a 12 to get this first one. I need the 12 to get the second one, so I'm 1 off, which means my explicit equation is f of n equals 3 plus 12 and minus 1. So it's basically kind of what we wrote there in equation form without all the words. Next, let's try this guy. Let's do purple. All right. So here, it's either a plus 5 or a times 2. Well, 10 plus 5 is not 20, but a times 2 is. So I'm going to go ahead and erase the plus 5. And that makes this geometric. How do we find the next term? Well, I'm going to multiply the previous term by 2, which what that looks like is f of, we start with the first term, 1 equal to 5. So our first term was 5. So my next term will be my previous term, n minus 1 times 2. Okay. So to find the nth term, I'm going to start with 1, then multiply by 2. I have to decide if it's n or n minus 1. Let's see. For my first term, I don't need 1, but I need 1 for my second term. So I'm 1 off times. Right? Which means my explicit equation is pretty much what I just said. F of n equals 1 times 2 of the caret, because it's a multiply, n minus 1 power. So, I don't start with 1, I start with 5. My goodness. First number here is 5. So I'm going to start with 5, and then I'm going to times 2 over and over and over. I was looking at the wrong one. All right, next, function C. Okay, well, let's try my two methods again. Let's do blue this time. All right, so 8 minus 9 gets me 17. Now times 2 point something. Let's hope our minus 9 works. 17 minus 9, that would be 26 minus 9. Okay, so we have an arithmetic. So how do we find the next term? Subtract 9 from the previous term, right? Or, oh, you know what? We should probably put it in terms of our common difference. So we're going to add a negative 9 to the previous term. That's a much better way of saying it, isn't it? So first term, we have a 1. So the first f of 1 equals a negative 8. And from there, we need to use f of n equals our f of n minus 1, our previous term, plus negative 9. We could also put minus 9. Either one works. All right, to find the nth term, we are going to start with -8, then subtract 9. Do I do it n times or n minus 1 times? Well, if I'm starting here, the second term only needs 1, so that's an n minus 1 times. So that means the explicit function is f of n equals, I'm going to start with a -8, then I'm going to minus 9 times n minus 1. Okay. Good. Works out. 4 we got here. Let's go to green. All right. Arithmetic, geometric, or neither. So it's either a +4 or a -3. Looks like it's going to be a -3. So let's get rid of our +4. So that makes this geometric. How do we find our next term? You multiply 3 by the previous term. So recursive equation. We have a first term, which is 2. And then to find my next one equals f of n minus 1. And then I'm going to times 3. All right, to find the nth term, I'm going to start with 2 and multiply 3. And again, it's that n minus 1 times. That first term is what we're given, so we don't need 1 for the first term. So f of n equals 2 times 3, a little caret, n minus 1 times. All right, we're cruising through these. Okay, here. So here we have, let's try this one. Here we have a +1 or times 1 1/3, right? Okay, so here's a +3. Oh, that's times 1 3/4, right? Because once and 3 more fourths of it. This is a +5. So I see a pattern. I see a pattern with my plussing. This one's a +7, so it's +1, +3, +5, +7, but that's not consistent. And the multiplication wasn't consistent because that's not even, they're all under 1, but they're not the same. Let's just double check. So 4 divided by 3 is 1 1/3. 7 divided by 4 is 1.75. 12 divided by 7. Yeah. So there's definitely no common ratio. And the arithmetic common difference is not there. So that one would be a neither. Woohoo! That one's done. We cannot do any of the rest of those when there is a neither, at least at this point. All right, 6. Here we are times 1/5. This is a times 1/5. Oh, times 1/5. All right, we are geometric. We are multiplying by 1/5. All right, so how to find the next term? You're going to multiply the previous by 1/5. a recursive equation is f of 1 equals 10. So our first term is 10 this time. And then to find our next one, we need to do n minus 1. The previous is a times 1/5. I'm going to put it in parentheses just because, yeah. All right. So it doesn't look like something over here. So I'm going to start with 10 and multiply by 1/5. I'm actually going to do it n minus 1 times. Again, just like on all of others, first one doesn't need 1, but the second one only needs 1. The third one only needs 2, etc., etc. All right, so f of n equals, starting with 10, I'm going to times my 1/5 to the n minus 1 power. All right. So ready for more is actually a little more complicated one. If you look at it a little bit more carefully, you can kind of work your way through this. Let's ignore the 0 and let's just go to the 1, because I think, isn't this the same one we had up here? It is. So let's see if we can figure this one out. So we said it was a +1, +3, +5, right? Well, if you look at this, those are a +2 difference. So there's still a pattern in there. And so let's say if I do, there's 2 sets of them. Okay, so think of 2 sets. If I take my x and I square it, well, I square it. So 0 squared plus what equals 3? Well, it's 3. But if I did 1 squared plus what equals 4? Well, 1 squared is 1. 1 plus 3 is 4. 2 squared plus what equals 7? 2 times 2 is 4. 4 plus 3 is 7. There we go. So my explicit equation in this case would be f of n equals my n to the second power is 3. Now the recursive is a little bit trickier. So f of 0 equals 3. So that's what we're starting with. And so what I'm actually doing for this one, so f of n equals the previous answer. And if you think about it, I'm taking 3 plus 4, 3 plus 1 to get 4, 4 plus 3 to get 7, 7 plus 5 to get 12. So if I actually wanted to try to find the equation to get 1, 3, 5, 7, my slope is 2, right? So think of it in terms of 2 of these minus 1. 2 eighths minus 1. 2 of those. I have a slope in there that is actually what's happening. So I'm adding on the slope of my line of 1, 3, 5, 7 to n minus 1. So 2 of these minus 1 gets me 1. 2 of these minus 1 3, 4. Yeah. So I'm adding 2 of these. 2 ones minus 1 is 1. 2 of these minus 1 is 3. 2 of these minus 1 is 5. 2 of these minus 1 is 7. So I'm taking my term number, doubling it to get what I'm adding each time. So that one is actually in Unit 7, getting into Unit 7 stuff. So just a little sight into what's coming ahead. All right, so for our takeaways, arithmetic, sequence, recursive equation. We have, it's usually written f of n equals f of n minus 1, and then we have plus our common difference, right? And so they either give us f of 0 equals some number or f of 1 equals some number, right? That's kind of what it looks like. And so then when we go to make the explicit equation from that, we have f of n equals that starting number plus b times our n, or we have f of n equals c plus d at our n minus 1, right? So those are kind of the two ways we will write that. Okay, so I'm going to scoot back up and just kind of stick with arithmetic sequence first. So how do we use that common difference in here? Common difference is added to the previous term. Okay, so that's what's right here. Okay, so here, how we use the common difference. Common difference is the slope, which is multiplied by n or n minus 1. Okay, so it's either just multiplied by n or it's n minus 1. So how do we use the first term? Well, it's either f of 1 or f of 0 is equal to the first term sequence. It's the starting point for adding common difference. Okay. So we either start here, and that's what we use to add to our common difference. So for our explicit equation, the first term is c in the equations. So we just have it as our starting point here. It's the starting plus what are we doing over and over. All right, let's look at geometric. So with the geometric one, we have f of n equals, and sometimes they'll put the ratio in front. I like to keep it behind, so it just helps keep it clearer for me, times r. So And then we either have f of 1 equals our starting number, or f of 0 equals c. I'm going to do this one up here too, just to show f of n equals, sometimes they will put r and then f of n minus 1, just to show that that's a multiply as well. They said, I think that gets you a little too jumbled myself, but sometimes the book will put that. So we'll go ahead and put it on here just so we have those two options. All right, and so then we do the explicit equation. We have f of n equals a times r to the n, or f of n equals a times r to the n minus 1, right? It's usually to the n or the n minus 1. Okay, so the question on this guy was, how do you use the common ratio or difference? So the common ratio is multiplied by the first term. Okay? And that's what we've done here. Here, down here, same idea. The common ratio is the number that is raised to the power of n, or n minus 1, the equation. Okay, so here it's our number that's repeated over and over, that's raised to the power. All right, so how do we use that starting point now? For f of 1 or f of 0 is equal to the first term in the sequence. It's the starting point for multiplying common ratio. All right, a lot of words on these. Okay, so down here then, the first term is a in the equations shown. So here we just have it as a. All right, quite a bit on that one, a little more involved. Let's see what our retrieval is. So find the common ratio for each geometric sequence. So we know it's geometric, which means 12 times what equals 36? That's a times 3, 36 times 3, yep. So common ratio is times 3. So 1/3 times 9 actually gets me a 3. 3 times 9 is 27. So 9 is our common ratio. Okay. Each problem below is an arithmetic sequence. Write the recursive and explicit equations for each sequence, then graph the sequence, making sure the scale is marked. All right. So arithmetic, +4, +4, and that's a +4. So I'm starting with my first term is 5. That's 1, 2, 3, 4. We always start with the first term. And then my next term is f of n minus 1 plus 4. So when I turn that to an explicit equation, use a different color for explicit, I know from what I was just doing up there, that's my first term plus 4. And since I'm starting with the first term up here, I don't need quite as many plus 4s as the term number. So there we go. There's our equation for that. Now for our graph, let's just go ahead and draw one down here. So I have 17, 1, 2, 3, 4, 5, 6, 7, 2, 4, 6, 8, 10, 12. That only goes up to 14. Let's just go ahead and go on up here. 16, 17's at the top. 1, 2, 3, 4, 5. And so what did I say? 2, 4, 6, 8, 10, 12, 14, 16. So 1 is 5, right in between here. 2 is 9, right in between here. 3 is 13, which is right in between here. And 4 is 17, which is right up here. And we're going to leave them disconnected because it's a list of numbers. All right, Rachel's grandmother gave her $40 for her birthday. She decided to put it in her piggy bank and save an additional 5 each week from mowing lawns. Model that sequence amount of money in a given week. All right, let's just go ahead and go F of, she got $40 for her birthday. So that's a starting amount of money. And what she did with that was she took that $40 and every time she added $5 each week, which means her initial, she starts with 40 and she adds 5 each week. And since the 40, the first week she does add 5, we don't need an n minus 0. All right, so let's do our graph. And 1, 2, 3, 4, 5, and 10, 20, 30, 40, 50, 60, 70, 80, 10, 20, 30, 40, 50, 60, 70. So here's her money, and here's her weeks. So 0, she has $40. You know what? I don't like the blue on here. That's kind of light. The first week she has 45. Then she has 50. Then she has 55. Then she has 60. Then she has 65. And so on. And it's not connected because she doesn't have money in between those times. Well, thanks for joining us. That was a long one. Have good day, and we'll see you next time. Bye.